Hello students, welcome in chapter 10, Vector Algebra. Students, today our last part of this chapter, and in this parts I explain only two remaining numerical for exercise 10 and miscellaneous examples, which is very most IMP. So in exercise 10, question 17, find the value of I dot j cross k plus j dot I cross k and plus k I dot j. Students, I think you know that it is a anti-clockwise rotations for your I, j and k. Yes, I cross j, definitely it will k. Next, j cross k, it is I, and k cross I is equal to j. That is your simple anti-clockwise rotation shortcut formula. If you moving a reverse clockwise, I dot k, it is minus j, k dot j minus I, and j dot I minus k. So your value I dot j cross k, which is I, plus j dot I cross k. I cross k, it is a reverse given. I write down minus j, and at the end of last k, I cross j. I cross j, it is k. Now students, I dot I, you know that it is a 1, either I magnitude the whole square. Same as minus j dot j magnitude whole square, and similarly k dot k magnitude whole square. It will be 1 unit vector, that also 1, and here students you are easily complete these solutions for question number 17. Now students, continue going ahead. Question number 19. This is a by mistake I written 17. Students, you just make your correction. It is question number 18, because up to 17 already I explained in last part. Now 19. Theta is the angle between any two vectors A and B, where A dot B is equal to A cross B. When theta is this, very easy students. If given A dot B magnitude is A cross B, so you know that both formula. Yes, A dot B, actually it is coming from cos theta. Cos theta is what? A dot B by modulus A modulus B, and students, that also known sin theta, A cross B by magnitude A magnitude B. This both value I will attach here and here. So what is A dot B? It is modulus A modulus B cos theta. Now I just using A dot B using is equal to A cross B. That is your magnitude A magnitude B cos theta. Same as that, here A cross B, it is modulus A modulus B sin theta. This cancel, and only sin and cos are equal. When they equal, yes, it is a tan theta 1, either theta become 45 degree, and that's here students angle between easily our two vectors. Now here students, our exercise done. Now I go to our miscellaneous example, which is very most IMP numericals. So now students, we going ahead. Miscellaneous example 32. Miscellaneous example 32. This IMP for exam. Find all unit vectors in xy plane. Just check your question. Find all unit vector in xy plane. Very easy students. First of all, I draw simple our in xy plane, x-axis, y-axis, x dash and y dash. Here your 90 degree origin. Now you will take one of the unit vector. It means I just dating one of the unit circle having radius r. That's the r radius. Yes, very easy. Here I consider one of the general point. It is a point plotting on the circle cos theta comma sin theta, and that's the radius is 1. Here radius I taking only 1. Students, you will check here perpendicular. Exactly, here point is a cos theta comma 0. That's the point is P dash, and this directions O to P dash plus P to P dash is equal to O to P. Yes, that's the triangle property. So students, I will take here, suppose this O to P dash directions, this R is what? This minus this, point plotting on the our x-axis. So cos theta comma 0 minus 0 0. So what's your OP dash directions? It is cos theta comma 0. It means cos theta I plus 0j. That's your first direction ready. Now I go to this P dash, but point taking on unit circle. So here also you can write down, suppose P general point cos theta sin theta on the unit circle. Unit circle having radius 1. Now I will check this direction, P dash P. Yes, so students, next I going P dash P is nothing, P minus P dash cos theta comma sin theta, and P dash cos theta comma 0. Now just to subtract it is 0, but that is sin theta. It means 0I plus sin theta j. That's your P dash P. Now triangle property, O to P dash to P is equal to OP, and definitely that is your unit circle because the radius is 1. I will take, and then also I prove by using magnitude of given directions. So finally, in a triangle, students, this triangle O P dash P, O P dash P, O to P dash directions plus P dash plus P directions is equal to O to P. Very easy. Now O to P dash already known I, cos theta I plus 0j. Same P dash P, 0I plus sin theta j, and is equal to OP same. Now you add it. Yes, it will get, what is the OP directions? It is cos theta I plus sin theta j, and that's your answer in all unit vectors. This is a single unit vector, or it is all, because theta is making that here degree P O P dash. Maybe theta is second quadrant, maybe third, maybe fourth. So I will take for every theta belongs to close bracket 0 to 2 pi. Yes, 0 to all in 2 pi up to first, second, third and fourth quadrant, students. Yes, theta unit vector, it is your OP directions. What? Cos theta I plus sin theta j. You also check here magnitude of OP. Definitely it is a 1 because magnitude of cos theta comma sin theta, it's covered to cos square plus sin square 1. It means, students, this is your answer. Yes, that's your required unit vectors having theta change, maybe 0 degree, 1, 2, 3, 4 up to 2 pi. Yes, that's your given question's answer. Now continue, students. Example 33. 33 also very easy, students. Yes, in the given vectors having values given A, B, C, D position vectors, define angle between AB and CD. Yes, position vector of A given here, A bar I plus J plus K. Next, B positions for B vectors. It is 2i plus 5j. And C vector with C vector positions given 3i plus 2j minus 3k. And D positions for D vectors are I minus 6j minus k. And question asking, find the angle between AB and CD. Yes, find angle between AB to CD and also prove, yes, it is collinear. AB and CD are collinear. Yes, one more time check questions. A to B, you are given A 1 1 1, yes, J 2 5, and C your value 3 2i 3k, and last D 1 minus 6 minus k. Students, I first decided our directions AB and CD. After that decided our angle. Very easy angle utilizations for cos theta apply. So first I going to AB directions. It is nothing, B positions minus A positions and apply their position vectors. So what's your B? B I have 2 5 0, A 1 1 1. So it is 2 minus 1 1 4 and minus 1. Second, going to CD directions. It is D position minus C positions, and D I have 1 minus 6 minus 1, and C position 3 2 minus 3. And simple derive value, it is minus 2 minus 6 minus 2 minus 8, and minus 1 plus 3, it is 2. Now students, I want to angle, so take magnitude and also taking dot product. So first take I magnitude of AB, 1 4 minus 1. So it is 1 16 1 root 18. Similarly students, magnitude of CD, that cover to minus 2 minus 8 2. I think you will check 2 common, best way. Remaining are minus 1 4 1. It is same as, yes, 16 17 and 18 root 18. Now both dot product, AB dot CD. Then dot product is a AB I have 1 4 minus 1 dot, CD minus 2 minus 8 2, and now you take between dot values. So minus 2, 8 4s are 32, and minus 2. Total 32, 34, 35, 36, minus 36. So now cos of angle between AB and CD, that become AB dot CD by magnitude AB, magnitude CD. Now dot clearly known, minus 36, and students here magnitude root 18, and CD is also 2 root 18. You will check 18 18, root 18 is 18, 18 to the 36, it is minus 36 by 36, it is minus 1. It means angle ready. What is the angle that? Yes, AB to CD, it is cos inverse minus 1, and it will be pi. Pi is the angle between both given students AB and CD directions. Now second proving, prove that it is collinear. Students, you say when they are collinear, angle making in the same directions, either in opposite direction. This is opposite indicate, answer is pi. Now that's why we will take AB and CD have opposite direction, therefore AB and CD are collinear. Yes, if you same direction going, either in opposite direction, this is opposite direction indicate 180 degree, just like that. If you draw roughly drawing here AB, here CD, that your degree is taking 180. Between that, it will be sure it is collinear. Now continue our example. Example number 34. Yes, 34 also. It is IMP for exam. A, B and C vector having value given for vectors A, B and C. Modulus of A 3, modulus of B 4 and modulus of C is equal to 5. Again 3, 4 and 5. Yes. And any two vectors is a sum of the other two. Yes, any one vector is perpendicular to sum of other two. Then find, you have to define magnitude of A plus B plus C, and that's your target. Students, here given vectors A, B, C, magnitude A, magnitude B, magnitude C given, and any one vector is perpendicular to other two, it means from given I will take A perpendicular to other two sum B plus C. It means, students, the dot product is 0. It means you will take A dot B plus A dot C. Same as secondly taking B is perpendicular to other two, it is A plus C. So that also, students, take B dot A plus C. And value wise B dot A plus B dot C. And third also, here any one vector is perpendicular to other two, means one time I take, students, A perpendicular, now B perpendicular, now third C. Indirectly that value is utilizations in the solutions. So also we will going that C perpendicular to A plus B. It means here also, students, perpendicular means dot product 0. It is C dot A plus B. So C dot A, C dot B is equal to 0. Now I want to A plus B plus C magnitude. So now I start in magnitude square. A plus B plus C the whole square. Actually it's come to dot product. Again A plus B plus C. And dot product taking simple in multiplied. So one by one I going that A dot A plus A dot B plus A dot C. Similarly, second chance. Now B dot A, B dot B and B dot C. Similarly, third chance. C dot A, C dot B and C dot C. Actually, students, that is, you know that very well, dot product magnitude whole square, and other are sum of that, it is 0. So can we write down here A magnitude whole square, B C, other are 2 pairing, check AB and AC, this AB and AC, this become a 0, other pair also 0, and that is, I know that modulus of A 3 square, B 4 square, C 5 square according to this given value. So it is 9, 16, 25, 50, and that's covered to same as it's a modulus A by direction, B direction, C whole square. Here same. Here same. Now I want to only magnitude. It's the cover root 50 and 50 known that 25 2s are, it is 5 root 2, and that value, students, A simple way we cover here. Example 34. Now going ahead, 35. Yes, continue. Example 35. That also IMP questions for exam level. Yes, it is the same pattern. Given vector A, B, C for 3 vectors A, B and C. A plus B plus C is a 0 vector and magnitude A1, magnitude B4 and modulus of C, which is 2. Find value of U vector. Yes, value for mu, which is mu, this is A dot B plus B dot C plus C dot A. Indirectly this process again I will show here, and in simple way we will cover our answer. So here from given we will start A plus B plus C is equal to 0. We check modulus both the sides and also taking square both the sides. It will be cover. Both are in dot products and here 0, and this calculations already show here easily. So A dot A, but you will write down again, it is new sum, Y dot B, A dot C. Now turn to second. Now B. B is your B dot A, B dot B, B dot C, and turn to C. C dot A, C dot B and C dot C. So does that's you known. Next B dot B known, C dot C known, and other are. You define your answers. So it is modulus A whole square, B whole square, and 2 times A dot B, B dot C and C dot A. So does here I take like terms A dot B and B dot A, both are plus. Now value put it successfully. A modulus 1 square, B 4 square, C 2 square plus 2, and that's the total given. It is a mu. Yes, I will write down mu and is equal to 0, and is all value put it from your given values. Now calculate one by one. So it will be covered in the total value. Here 1, 4 square 16, 2 square is 4, and plus 2 mu as it is. So 16, 20, 21 is equal to minus 2 mu. So mu is equal to minus 21 by 2. And that's the students, easily your answer done. Now example 36, which is very most IMP in board level, many time asking in the board exam. Question number example 36. Now students, the question is 36 examples. If with reference to the right-handed system of mutually perpendicular unit vectors I, j, k, alpha 2i minus j, beta 2i plus j minus 3k, then express beta vector in the form of beta is equal to beta 1 plus beta 2, where beta 1 is parallel to alpha and beta 2 is perpendicular to alpha. Students, perpendicular, you know that it is dot product 0. Parallel also known, having same directions. Means I will take here beta 1 is equal to something constant lambda either k with alpha. And here I will start our terms according to these given parts. From given, you will take your alpha vectors, this one 3 minus 1 0, and students beta vector which is 2 1 and minus 3. Now beta 1 is perpendicular to alpha, and this you given that beta 1 plus beta 2, it's very simple students. Now if beta vector is in form of given beta 1 plus beta 2, this is your final answer. At the end of this sum I will stop there, because beta 1 and beta 2 I will find out and putting their values. Now respectively start one by one, parallel also and perpendicular. So I first utilization this one. If beta 1 is parallel to alpha vector. Parallel means students you will check in this symbol, and definitely having same direction you will take something lambda constant, and lambda you know that alpha form, sorry lambda is unknown, alpha known. What is the alpha? 3 minus 1 0. So beta 1 is clear that 3 lambda minus lambda 0. Same as students. Now I will take perpendicular. Now continue. If beta 2 is perpendicular to what, that alpha, so beta 2 you will take perpendicular with alpha, so dot product 0. So students, beta 2 dot alpha is equal to 0. Beta 2 unknown, but alpha known. No, what's the alpha students? 3 minus 1 0. Here you also stop. Now wait, I will find out beta 2 from these equations. So beta already known, beta is equal to what? Beta 1 plus beta 2, and beta you value known that. So but beta value is actually beta 1 plus beta 2. What's your beta? This your beta 2 1 minus 3. Beta 1 here known 3 lambda minus lambda 0 plus beta 2. Now define beta 2. So your value for beta 2, this minus that. So my answer is students 2 minus 3 lambda, next 1 plus lambda and minus 3. Again check this right side value, convert left side. 2 minus 3 lambda, 1 plus lambda and minus 3 minus 0. And this beta 2 I attach here. And you will get one constant. Yes, that's the equation number 1 taking. Yes. So we are from 1. Continue. Beta 2 is that 2 minus 3 lambda, 1 plus lambda, minus 3, dot 3 minus 1 0. So my answer is 3 with the 2 minus 3 lambda, minus 1 with the 1 plus lambda and 0 into minus 3. It is totally 0. So here students 6, 3 3 is a 9 lambda, minus 1 minus lambda. So total cover 6 minus 1. It is your 5, and that become 10 lambda. It means 5 is equal to 10 lambda. Lambda become 5 by 10, which is half. This is only one constant I will define here. Now students, wait and check your question. What is the asking? It is represent, express beta is equal to beta 1 plus beta 2. It means I will now find out beta 1. This lambda, put it here in the beta 1, put it here in beta 2. That's your final ending to cover both summations. So one by one I going ahead in the parts of beta 1 and beta 2. First I put it in the beta 1. So your value become beta 1 3 lambda minus lambda 0. And what's the lambda? It is half, minus half and 0. And also students, beta 2, it will be cover to that one, 2 minus 3 lambda. Next 1 plus lambda. Next minus 3, and apply that 2 minus 3, lambda become half, 1 plus half and minus 3. So my answer is 2 to the 4 minus 3 by 2. It is 3 by 2 and minus 3. It means half comma 3 by 2 comma minus 3, that is your beta 2. Now you will check final expressions. Beta is actually beta 1 plus beta 2. What is your beta 1? Yes, that one. 3 by 2i minus 1 by 2j plus 0k plus beta 2, that's one. Half j I plus 3 by 2j minus 3k, and you check this total is actually beta. 3 by 2 and 1 by 2, 4 by 2, it is 2. Check, your beta is 2. Yes. Next, minus half and 3 by 2, 1. It is yes. And 0 and minus 3k, it is minus 3k. It means your final cover, that's what? 2i minus 1j plus 1j minus 3k, that's your beta. And these expressions, students, that's your final target for this numerical. And here students, our this all examples and this chapter also students, vector algebra ending here. In this next part students, now I going to next day, yes, chapter number 11 in 3D lines and plane. Bye bye.